Thank you so much, and thank you for giving me the opportunity to present here. And as Steve said, I do have a background from India, so I apologize for my accent right at the beginning, because you will see that accent in my presentation all the time. I picked up the Canadian accent a little, but not a lot. And I love the accent here, so I can tell you, whenever I come, this is my second conference here, and I love to be here. I learn a lot. You guys are doing wonderful things. North America is far, far behind as far as the transit and the technology is concerned. So it really amazes me when I come here and learn the new things. I can give you one context. I heard in the morning the presentation from TFL, and their daily ridership is close to 30 million. Ridership in New York for the whole year is 23 million. So I can tell you that very frankly, you guys are way ahead of us. And we are picking up, we are trying to implement a lot of things. York has been a leader as far as the implementation of technology is concerned. So our ridership has grown a lot, but still we need to do a lot of catching up compared to Europe. The subject which I'm going to speak to you could be a little dull, it could be a little boring, but it's very important from my implementation perspective as far as the technology is concerned. So please bear with me, and I'll try to make it as interesting as possible. A quick show of hands. How many have you heard about ITS architecture? Okay, not a lot. How many have you used ITS architecture in a project planning? Okay, one person. So that at least encourages me that what I'm trying to speak to you is could be of interest to you. There is an ITS architecture in Europe. I was doing the research before coming here, and it's called European ITS Framework Architecture, and also FRAME in short. But what I'm going to show to you is the Canadian ITS architecture. And actually, I was part of the team which developed Canadian ITS architecture in 2001. And since then, we have updated the ITS architecture because the technology has advanced and changed so much. And it's part of a Transport Canada initiative. Also, I just wanted to share with you is that I also chair a technical committee of ITS Canada, which is called Advanced Public Transit Systems Committee. And one of my mandate is to promote the use of ITS in smaller systems across Canada. So we are still trying to educate and still trying to bring the awareness about the technology in smaller municipalities. And when I say smaller municipalities, these municipalities could be running probably 10, 20, or 30 buses. There are municipalities across Canada which run those kind of transit systems. So we are still trying to promote the use of technology. Okay, so as I promised, here where I'm from, we are located just north of Toronto, with a population of about 1 million people, and as I said, our ridership is about 23 million. Thank you. So what is ITS architecture? We are going to cover these three questions, or I'm going to cover these three questions throughout my presentation. And why do we need ITS architecture? How does it work? And how do we use it? So as the technologies have developed and they are becoming more sophisticated and the equipment is getting more sophisticated, means the smartphones are getting outdated probably every 2 years, one particular model, maybe sooner. And we have more stakeholders. You heard from Tim about different geographical areas which we need to cover for any technology. We need to have interfaces with the other agencies. There are special interest groups. You heard about the free card where people are being given free cards to travel. And then there are more interdependencies. They both are internal and external. I mean, if you look at transit, if you look at traffic, if you look at any other department within your own organization, you need to have the information flow across different systems. So there are dependencies which are internal, there are dependencies which are external. What I mean by external is, think about between Canada and US, when a person is traveling, we cross border, and that information is shared between Canada and US. And that is so seamless and transparent. I can tell you, when I cross, I have a profile because I have a Honda car, I have a wife, and I have 2 daughters. So when I'm crossing, when I'm answering the questions at the customs border, they're profiling me. And the profile matches with the person, they let me go in 10 seconds. If I change my car, and if I'm only with my wife, they ask me a lot of extra questions because my daughters are missing and I have a different car. So think about the information exchange between external agencies and how important it has become in the world we are living. I'm just going to give you an example. When you get up early in the morning and you're planning your journey to go to work, you want everything on your handheld device, on your mobile device. You want to know how long it's going to take, what the traffic conditions are, how much do I need to pay, are there any incidents, accidents which I need to be aware of, do I need to change my route? You want everything on your handheld device. If you've already started your journey, you want to be alerted. Do I need to take a different route? Has there been an accident in the last 5 minutes or 10 minutes? You need to be alerted because that has become our expectation. We do not want anything but the best from the service providers. So as a user also, that has become my expectation, that I want the best. When I arrive at the bus station or a train station, I want to reserve my parking because I want my parking close to my station so that I can run and get the next train. How do I reserve my parking? So that's the expectation from the user. Well, in the era of the electric cars, am I going to have a charging station at my parking spot? There could be only so much or limited charging stations. So I need to know that the car which I'm going to reserve would have a charging station. And then the travel on the transit. Which train am I going to connect? And on the route where I transfer, are the other trains also on time? And this gives you a complete picture as to how soon or how late you're going to arrive at work. So that has become the expectation. And how do we achieve it? Architecture does provide you some benefit integrating different systems together. And as I said, it is becoming more and more important because of the advancement in the technology. So what is ITS architecture? So it's a framework. It's a framework to identify different connections, whether they're internal or external, as I mentioned to you and gave you a few examples. It's a vocabulary, because when I'm speaking with my colleague, speaking with the team, we need to be consistent as to what I mean. Means ITS itself, or the different terminologies which we use. So ATMS means Advanced Traffic Management System. Everybody knows, should know or need to know what ATMS means. And then it guides you to develop a project plan which is consistent with the architecture and the technology. So the Canadian ITS architecture and again your own European ITS architecture, they both are available online. All what you need to do is answer a few questions and you will be able to get a copy of the ITS architecture. So let me cover this as to what ITS architecture, what it is not. So it's not a design document, okay? So if you're looking to design a new ITS system, please do not use ITS architecture. It's going to help you getting where you want to be, but it's not a design document. It's not an institutional or a development process. Okay? It would not guide you dealing with the institutional challenges or how you come to an understanding, sharing the information between the different agencies or organizations. That is outside the ITS architecture. And it's not a technology perspective. As to what kind of technologies do I need to make it happen. It just guides you through the process to get all the interconnections and sharing of information. Sorry, I should have. So how does it work? I'm going to show you a few slides. And this is where the dull part starts, okay? So basically the architecture is the logical and the physical architecture. And then we feed the information as to how the architecture and the structure works. So we start with the user services. And the user services are basically the requirements which the user is looking for from the system. So one example which I've given there is an incident management. If there is an incident on a highway or a motorway, and how do you deal with it? How do you inform the police? How do you inform your control center? How the information gets passed on to different agencies to react to the incident? So that is your user service or the user requirement. But then that feeds to the logical architecture, which determines as to what functions do we need to provide that user service. So in this particular case, we need to detect incident, and then we need to verify incident. So the detection could come from your sensors embedded in the pavement, or it could be from the video. The verification could be physical verification, that if you have a police officer out there in the vicinity, they could go and verify it, but you may have the CCTV camera system. And you can verify the incident using a CCTV camera system. And then, where the functions are, that is the physical architecture or the physical architecture of the ITS architecture. So it could be the control center, because the control center is coordinating the incident management. It could be the police control center, because they are arranging the dispatch of the police officer. It could be the emergency services, anybody. So it's physically where the function lies. That is the part of the physical architecture. Service packages and standards. What the Canadian ITS architecture has done is this whole logical and the physical architecture could be very confusing, and I'm telling you, you need to start from somewhere. So we have packaged different portions of architecture together so that you don't have to look for the complete architecture. You can just use the service packages and start identifying as to where you need to go for the physical and the logical architecture. So traffic management could be one service package, but the traffic management may have different user services. So that's how we have packaged it. So it's like a vertical slice of the architecture. And then the standards. So once you have identified different components and how the data is flowing between different systems, you need to identify some standards. Because if you are sharing the information between two different agencies, you need to speak the same language. And the standards enable you to speak the same language. So I'm sure you have used the Google's GTFS feed. Many of you, I'm sure you're using it. So that's one of the example of the standards. In US, they have an MCRP protocol, which is used for communication with the variable message signs. So those are the examples of the standards. So I've covered a lot of other slides. I'm going to quickly go through it. So user service I have already mentioned very briefly. There are 37 different types of user services in the Canadian ITS architecture. And so one example could be a route guidance and navigation. Another example is a public transport management, which is a user service as part of the architecture. And these are the packages which I mentioned to you. So 37 different types of user services, but we have packaged them under 9 different headings. I don't have to explain this to you. I'm not going to read the slide to you. You can understand it. You all know this. And then the user services are further broken down into the sub-services. And again, you can read this, you can download the architecture. There are over close to 100 different user sub-services which feed into the user services, and then the user services they feed back into into the service packages. So the logical architecture. As I said, logical architecture defines what functions do you need. So everything what you see in yellow there, these are the functions within each service packages. And I'm taking only one example, but there are different functions which lie within those service packages. So once you have identified as to what functions do you need to provide, you can start working on the logical architecture. I'm not going to explain this to you, okay? It's complicated, and I've only shown you a few examples here. I'm going to just explain a couple of things. The theme of this conference is transport ticketing and around ticketing. So if you look at the top left corner, how the data flows between the credit card and debit card service providers and the users. Or it's not that simple. Only one arrow is not going to define all that data flow. But when the user serves services and as you go through the process, it identifies each and every data flow which is required for providing a contactless payment, fair payment. So that's an example. I mentioned to you about the incident management on the top right corner. You can see how the information flows between the control center, emergency services, and the user out on the street and the road. So that you can identify here. How you go about doing it, you go right from the top, start identifying all the data flow diagrams at different levels. As you reach at the bottom, you will have to start writing specifications now for the processes. And we also call everything which terminates at the bottom, we call it terminators because you cannot go any further. So that's where you start writing the specifications, and then you go up, and then that becomes part of your specification document for your project plan. So the physical architecture. This is an example of a physical architecture. And typically in any ITS environment, you have 4 different areas. You have the traveler, you have the vehicle, you have the field, the roads, the tracks and everything, and then you have the control center. So this identifies the interconnection between those 4 distinct groups. And I'll take an example at the end to show you as to how you go about defining your project and the project plan. Service packages, as I mentioned earlier. So if you look at the technical framework, it could be very challenging and daunting, but you need to make it a little easy depending upon as to what type of services do you want to provide. And that is achieved through the service packages. I'll let you read it, but then, as I said, it maps very closely to the requirement or your project which you are trying to implement. So the architecture will drill down you to the transit vehicle and the transit management system and how the data flows between the transit vehicle and your transit management systems. Another example is high occupancy lane management. I'm not sure whether this terminology is used here, but this is a terminology which is used in North America where we allow the car or a bus to go through a lane which is dedicated only for the cars where you have 2 or more people riding in the car. Single occupancy cars are very popular in North America, okay? The place where I live, in New York, has the highest average number of cars per household. You want to take a guess? It's 2.6 or something. And highest number of 3 and more car garage households there in New York. That's the culture. We have somehow or other we have to maybe not break the culture, but at least maybe modify that culture so that people start using the transit and the public transport allowed. And the standards I mentioned to you, and these are the standards when you go down to the level of process specifications, you need to start identifying what standards do I need to use to have the data flow and back and forth between two different systems. CIRI is one of your European standard which you use for sharing the information as far as the travel information systems are concerned. And how do I use it? So you may be asking the question is this applicable only for the new systems, or can we do something about our existing systems? Well, you can do certainly something about the existing systems also, because we all go through upgrades and change in the technology. Tim mentioned about 6 different suppliers and 10 different types of equipment in their system. So when we are looking to upgrade our system, we do have opportunity to look into the ITS architecture and see if we have better opportunity to share that information. And Tim, I forgot to mention one thing. As a smart card implementation does take time, so I can assure you in Toronto, we started in 2006, and we were able to implement it only in 2011. So 5 years. It does take time. It's not easy. So if you're looking for a new project, you have your local and regional requirements. All what you need to do is integrate the ITS architecture, bring your auxiliary requirements into the architecture discussion, or the requirement discussion, and then you map your requirements to the Canadian or the national ITS architecture. I'm not going to, I do have some time actually, I can quickly explain this to you. So what you see here is the process which we can follow to map the requirements for a new project or an existing project with the Canadian ITS architecture or any other ITS architecture. So you have an inventory of the existing systems, and then how does these systems they are mapped to the ITS architecture for Canada. You identify that, then you identify the plant services, all the plant requirements for the new systems, and then you map it again to the subsystems of the architecture. And then, as I was mentioning, the auxiliary or the local requirements, you map it, and then you have a customized architecture for the project, which includes both the existing and the new systems. And then you can go down further down, identifying all the logical architecture and their process specifications. So since I work for transit, I'm just going to take the example of, sorry. So if you look at the transit vehicle as to where it is and how we provide that information to the customers, so all the subsystems identified in the red rectangle, they constitute and they provide the information from different physical architecture back to the control center, and we disseminate that information to the traveler. But I'm making it very simple, look very simple here, because I only had 20 minutes time and I had the luxury of getting another 10 minutes, so I'm taking a little more time explaining all these slides to you. Another way of presenting the same thing when you are drilling down into your requirements, where this information is coming from, and how you disseminate that information to the customer. So in summary, the architecture is a tool to provide a framework and guidance for planning and deployment of ITS projects. User services and the requirements drive what the architecture covers. And as I mentioned to you at the beginning, is the architecture only includes the physical and the logical architecture. And then all the advantages of the service packages, existing elements. And last point is very important actually. Service packages can be modified or combined to produce high-level physical representation for the regional and the national projects. So that is very important. So you don't have to just accept the way the service packages are provided. You can always combine two service packages into one, if need, to even share the information outside the service package. And I had to show you this particular slide. We have just opened our bus rapid transit system. It is considered to be one of the state-of-art transit system in North America. And we are saving close to 30% of the travel time in the stretch where we have opened this system. And it has all the bells and whistles of ITS integrated with the station and with the system. So whether you call it customer information, panic button, cameras, fiber optic communication, everything is integrated with this. And we take pride having implemented this BRT system. So that's my contact detail. If you have any follow-up question about the architecture, if you want to send me a quick email, feel free to do so. I would love to get in touch with you and provide answers to your questions. So anyway, I still have about 4 minutes, so I'm open for questions now. Or it was a very boring subject, as I said. We don't have any questions. I didn't see anybody sleeping here.
Oh,
so I have one question here. Thank you.
So how does this work now for the systems in Canada generally? I mean, is this an architecture for new systems that you're introducing, like your bus rapid transit system, or can it also be used for transferring legacy systems into the same approach? How does it use in that sort of the context of now?
Yeah, so, no, that's a very good question. As I mentioned, that it doesn't mean that you already have a system and where you did not follow the ITS architecture during the design. That does not mean that you cannot follow the architecture if you are thinking of upgrading the system or bringing in some additional component to the system. So any upgrade opportunity, any changes to the existing system gives you that opportunity to look at the architecture and see, can I do a little better? Or am I already doing better? If you're already doing better, then there's no point, there's no reason. But if you can improve the information flow across the systems, I'm sure you all should look into looking at the ITS architecture. It just gives you a framework, as I said. But yeah, certainly for all the new projects, I would highly encourage you to look at the architecture and see whether we can do better. But yeah, it does provide you the opportunity for existing system. Thank you. Seems like it was a boring and dull subject. Well, I told you, I warned you at the beginning. Okay. Thank you.